Number 18, when I look at that equation, the first thing I see is a quadratic form of an equation. We have a quadratic term with a linear term, so we can't isolate our terms. On the others that we've looked at prior to this, in our test, we haven't had the cosecant squared, or the cosecant term, the linear term. We just had the squared term. In that case, you may isolate this and find what the cosecant is. But as soon as you introduce that linear term, you cannot isolate your cosecant. So we're going to do a different strategy on this one. It's just like if you would have x squared minus x plus 9 equals 11. If it's a quadratic equation, you would get one side equal to 0 and then factor. So that's what we're going to do on this one. Cosecant squared of x minus the cosecant of x. Then subtracting your 11 gives you a negative 2 equals 0. Trinomials, if factorable, factor into two binomials. So we're going to attempt to factor this into two binomials and set equal to 0. Which means the cosecant of x times the cosecant of x. Signs have to be opposite, plus and minus. Since we have a negative middle term, I want a negative 2 plus 1. Okay, at this point, we apply our zero factor theorem. Either the cosecant of x plus 1 equals 0, or the cosecant of x minus 2 has to equal 0. According to our zero factor theorem, if we've got two numbers that are multiplied together and the answer is 0, one of those two factors must be 0. So I'm going to solve this one. Now it's a linear in terms of cosecant, so the cosecant of x equals a negative 1, which means the angle we're looking for has a cosecant value of a negative 1. And this one, I'm just going to come over here and solve this one. We have a cosecant of x would have to equal a 2, so we're looking for an angle whose cosecant value is a positive 2, or positive 2 over 1, and maybe I want to look at this as over 1 as well. Now I'm going to go find those angles by looking at some reference triangles. Cosecants go harvest y values in essence. We want to know where is your y value equal to a negative 1. The only place your y value is equal to a negative 1 is sitting right down here on negative or positive 3 pi halves. So that's our angle that's going to satisfy this part of our equation. So 3 pi halves. And with the next one, we have a cosecant value where we have an r value over an x, r value over a y value. I'll put that in there correctly. So I'm going to draw a reference triangle where the radius has a length of 2 and the y value has a length of 1. There's our square root of 3, or 1, 2 square root of 3. That makes this a pi 6. Cosecants are positive only in the first and the second quadrant. So now I know I got another reference triangle sitting over here in the second quadrant that has the same requirements as we just did in the first. So one of our angles that satisfies our equation is pi 6. The other one is sitting over here in the second quadrant, which is 5 pi 6. So our solution set then becomes pi 6, 5 pi 6, and 3 pi halves.